Good day, everybody. So my name is Elamvaluthi. So my qualification is MTech Chemical Engineering. I have done MTech from IIT Chennai. I have more than about 40 years of experience, out of which 21 years experience in process design. So this advanced process design course organized by Stepin Engineering. So just to introduce about our Stepin Engineering, it offers targeted training for chemical and petrochemical engineers in the oil and gas sector, enhancing skills and fostering career progression. The Advanced Process Design program focuses on efficient, safe industrial process design, covering simulation, equipment selection, and sustainability. It equips engineers with the essential knowledge for career advancement and adaptability in the dynamic oil and gas industries. Because I come across many engineers, process engineers, so working in process design consultants. So what I understand is actually they lack in many of the fundamental design rules. Like for example, I have seen many engineers actually just going through the Excel spreadsheet and doing calculations and design, etc. But that is not the way, because the design should be based on good engineering practice, codes and standards. So this course contents actually starts from the first day. So is to discuss on the PFD, P&ID, legends and symbol. The second module is on the line sizing, and the third module is on the pump sizing and design calculations. And the fourth, fifth, sixth, seventh, okay? We organized 4 modules. Each module will consist of about 3 hours. 4 modules actually PipeNet simulation, okay? Because this 4 modules on PipeNet simulation will be a live demonstration. Live demonstration instance actually will be demonstrating PipeNet simulation. So how the how you start preparing from scratch. So the next, the module 9 and 10 actually it's a PSV design calculations and PSV sizing calculations, etc. So to repeat, to emphasize the course contents, although it is the title is actually Advanced Process Design, but the course contents are designed in such a way that the other disciplines like, mechanical, piping, instrumentation, electrical, civil also, they will also benefit. Because see, process, like for example, suppose if we take the PFD and P&ID. So P&ID is actually is a mother document. So P&ID is a basic document prepared in the engineering. This actually process design is actually the engineering in any industries. Okay, so the P&ID is a basic document, so which actually being used as a basis by downstream disciplines like piping, mechanical, instrumentation, electrical, and civil. Because P&ID only talks about so what are the various equipments and available in the in the entire plant. What are the instrumentations available? So how the electrical systems are inbuilt, how the process controls are defined. So what are the various civil structural equipments are involved. So you go, actually P&ID is actually a global document. It is actually, it's a picture view of any process industry, whether it is a fertilizer industry or pharmaceutical or oil and gas front end or back end, or anything you talk about, okay, paper industry, anything. So P&ID is a basic document. So P&ID will be used for not only for design, but you go for downstream for construction, pre-commissioning, commissioning, and in future you want to do some modification in the plant, people will ask, where is a P&ID? So P&ID is a mother document. So the reason why I'm saying insisting on P&ID, because the other disciplines also, they are also involved. They should also know how to read the P&ID. If the piping instrumentation guy doesn't know how to read the P&ID, you will not be able to do the design. The civil structural man will not understand what are the civil related equipments, okay? So built in this plant, then you will not be able, he is not a civil engineer. Electrical engineer should know what are the motors available, how the motors are, okay, whether it is a diesel driven or electrical driven, whatever it is, okay. All those things actually the electrical person also should know. So that is actually the contents of the first day course, actually P&ID, which we are going to talk for about 3 hours, including. So starting from the process flow diagram. Process flow diagram, it just explains the basis, okay, how the process looks like. Starting from the raw material, how the product actually, how it goes. So that is the sequence of operation, actually PFD. PFD is just outline of the entire industries. But PFD is actually is the one based on which actually you do the detailed design, the equipment sizing, then you go for safety philosophy, fire water system, network, etc., etc. So that is the course contents on the first day, which I advise all the disciplines to, okay, so to get benefited, to attend this first day and get benefited, so that you should know, so that you will not go and ask somebody, okay. People, if you go ask simple basic doubts with other discipline, they will mock at you, okay. So that's what I can say, okay. You should be able to read the P&ID. That's what I'm saying, okay. With any discipline, you should be able to read the P&ID. So all those things are explained in the first day course. The second course is on the line sizing. See, the line sizing actually is hydraulics and line sizing is the basic fundamental design aspect, which especially the process man and piping man should understand. Suppose I have a line, okay, an equipment coming, is whether it is the equipment connected to the pump with the suction line, and pump is pumping to some more discharge, okay, the equipment which is operating at different pressures. So you should know what line size I am going to do, okay, whether it is going to be 4 inch or 6 inch or 7. So the line sizing, that's what I taught. Before that, actually you should know what is flowing inside the line. Without that, you will not be able to do the line sizing. So what this course content actually on the second day on the line sizing, it explains not just the theoretical calculation. It is based on the API and the good engineering practice of Shell DEP. Shell DEP, one of the standard accepted throughout the world, okay. So if you say that I follow the Shell DEP, I did that, because the line sizing mostly based on the pressure drop calculation on the velocity, etc. Suppose you are assuming 3 meter per second, 5 meter per second. The client will ask, what is the basis of this? Once you refer to the standard DEP, so and so section actually it defines. So for this particular survey, for the particular application, actually the lines should be so much. So the client actually after, okay, fine. Because what the client wants actually, he doesn't want, okay. What they want is actually, what is the basis on which actually all these designs are carried out. You show me the standard, you go show me the good engineering practice, where it is, that's what. So that's what actually emphasizes this course. It is not just talking and going, it shows where this number has taken from, okay. So delta P per 100, if it is a gravity line, the line, okay, the velocity should not be more than 1 meter per second. That is not my design. It is something which is stated in the good engineering practice like Shell DEP, etc., which I am going to not only just, I am going to give the reference, okay, where it is stated, okay. So there are so many things in the line sizing which already I have given in the course contents, okay. So we are going to talk about the line sizing for single phase. If it is going to be a pure liquid, what is the criteria as per API 14? If it is going to be a two phase, so what is the erosion velocity? What is the mean erosion velocity? How important it is? Then how do you calculate the erosion velocity? So when I talk about the erosion velocity, actually the C factor, if you look at API 14, where it is stated, what is the C factor? How much is the C factor? It can vary from 100 to 250. Then what value I will take? Based on which actually? So all this actually will be discussed in the line sizing. Then comes to the third day, actually it's a pumps and hydraulics. Pump sizing and hydraulics is a very important subject, okay. So the most important concept is actually NPSH, net positive suction net available. If you don't know how to do the NPSH calculation, the pump will not work. You will make the data sheet and buy the pump, finally you put it in service, it will not work. Then you go back and check do the postmortem, then you come to that the NPSH is not correct, the vapor pressure not taken. So as I said, actually it is a very important subject. Actually, if you don't know how to calculate the NPSH, okay, you land up in the problem finally at the commissioning stage, then you'll go back and do the postmortem. the vapor pressure may not have been taken properly. Where to take the vapor pressure from? These are the things we are going to discuss during the, okay, during the training program. Okay. Pump sizing hydraulics. Pumps actually suction. Okay, how do you do the suction line sizing? Okay, how do you estimate the pressure drop? What is the velocity you take? How do you do the discharge line sizing? The discharge pump discharge actually is connected to pressure system. So how do you do it? Okay, so which software you are going to use? Whether you use ICs or you will use okay, the software specified by client. But ISIS actually is accepted package, which we are, although we are not going to do live demonstration of ISIS, but we are going to explain to you how the line sizing is done during, okay, using the ISIS simulation. Okay, we have a manual, ISIS in detailed manual is there. I will show you because I used ISIS very extensively. So I can demonstrate using the manual. So how the line sizing can be done for various services. Like I said before, whether it is a single phase, whether gas phase, liquid phase, two-phase phase, or if it turns into solids. So all these scenarios will be explained. So the next one is actually the most important course module is actually PipeNet. So the PipeNet simulation, actually PipeNet is a very, very important software next to ISIS. ISIS and PipeNet, if you know, you can manage your process design. If you don't know ISIS and PipeNet, you will not be able to survey in process design. Because nowadays, actually, everything is, people first ask which software you have used. If it is just one single line, or okay, and a couple of lines connected together and discharging, then it is okay. We can do some manual calculation and manage. And even with ISIS, we can manage. But when it comes to a complex network, so like you know, if we talk about the refinery network, if you want to do the fire water system complete network for the entire refinery cycle, I have seen some refineries 2 kilometer by 3 kilometer. Such a big network, such a big refinery. How do you do the manual? So there will be about close to 300 fire hydrants and monitors. Okay, so there will be firefighting apparatus close to about 800. So there will be hundreds of loops will be there. And so these things you cannot do it manually, or even ISIS cannot be doing. ISIS, there is a limitation. Although ISIS is a very good software, but there is a number of limitations, like, you know, you will not be able to say, like, you know, fix multiple targets and okay, you will not be able to achieve through ISIS, but it can be done through PipeNet model. The PipeNet model, actually, the first day what we are going to do, actually PipeNet is a vast okay, simulation package. It has got steady state, it has got transit, and the steady track, actually spray model is that. Okay, so here actually the first day we are going to focus on the steady state modeling. So suppose you have a network, so the network consists of various outlets, multiple outlets, and the entire piping actual network is supplied by a couple of pumps and connected in parallel or series. So suppose I open multiple outlets, what will be the pump discharge pressure, how the pump will behave, whether it will be able to work. So what will be the kilowatt rating and all those things we are going to discuss at the first day. Second day, actually what we have planned, okay, our model actually is a transit analysis. So transit actually is a surgery. So model is, yeah. Okay, sorry, okay, yeah. Standard model, transit model. This is a model. The transit actually model is model number 6. See, actually in this thing, transit, surgeon is a very important topic because any project, okay, any system running, whether it is a pump or in a running plant, suddenly the pump trips, okay. So when the pump trips, actually what is the impact on the piping system? What is the impact on the discharge pressure? How the network will behave? Whether the entire piping system will design can withstand that? Because there will be a sudden increase in pressure. The increase in pressure, actually, to what extent it will reach, we don't know. Unless otherwise you do the simulation and through transit, and you will not be able to understand. Because these things are very important when you build a new plant. transient analysis has to be done for each and every pump. Not only for the pump, where there is a control valve there, where there is a ESD, PSV is there. When the ESD valve closes, okay, ESD valve normally closes very fast, okay. So within closes in a few seconds. So what will happen? What is the impact on the pump discharge? What will happen to piping design pressure? Whether it will suit up until, so whether the pipe is designed for such a high pressure, surge pressure. These are the things to be checked during the design stage. So if you are not piping is not able to withstand the piping, then you have to go for the higher rating. These things will be demonstrated through the transient analysis. So model number 7, we are going to talk about the fire water foam and demand calculations. So that we are going to live demonstrate the fire water network. Okay, complete the bill and open the hydrants, open the monitors, and see open the deluge valves. And so if you have a sprinkler system, like for example, sprinkler system is a basic requirement for the hydrocarbon system, like for hydrocarbon storage tank. So when the storage tank is under fire, then deluge valve will open, okay, then sprinkler will start pouring. So what will impact on whether the fire water pump, main pump is designed for such a huge capacity. These are the things will be demonstrated in the fire water and pump characteristics of the PipeNet. The next module actually is on the, okay, that is actually complex fire water network actually we are going to build, and we are building actually what inputs actually to be taken in the PipeNet model, like for example, hydrants if you talk about, it is a K factor. How the K factor is, okay, what value you take K factor, whether you take it from the simulation itself or you go through the vendor package and vendor catalog and take the values from that. These are the things actually we will be discussing on the model number 7. The next model actually the PSV is a very important topic. PSV is actually the basic requirement for any, because the equipment actually during operation actually there could be umpteen number of abnormalities can take place especially during commissioning and startup and shutdown. So when the design pressure and the operating pressure of the particular equipment increases, so there could be catastrophic event also, catastrophic failure can take place. These things how you avoid. So you need to go for suitable protection. How do you protect the equipment? How do you protect the pipelines? So you need to have some kind of protection measures like a pressure safety valve. So how do you design? So what kind of a pressure safety valve? There are so many types of pressure safety valves available in the system. Whether it is going to be a thermal relief valve, whether it is going to be a pilot operated relief valve or normal conventional relief valve. How do you? Because if you go for separate design, it's like a pilot operated valve. Pilot operated VSV is actually almost 10 times cost like the conventional pressure relief valve. I cannot just blindly put pilot operated relief valve and say that my system is safe. No, it is not the way. The design should be fit for purpose, okay? Where it is required only conventional relief valve, I cannot go for pilot operated relief valve. These are the things will be discussed and demonstrated in the module number, okay, 8, 9, and 10. 10 actually it is going to be based on the 521 and 520 and 520. Okay, actual PSV sizing calculation we are going to live demonstrate and calculation will demonstrate. Suppose if it is a gas phase, if it is going to be a liquid phase, so how do you do that? How do you select the design pressure? How do you design this thing? Okay, how do you estimate the RFS size required for the PSV? After I estimated the RFS size, how to go and pick up this thing? Okay, PSV. So with respect to 526, API 526. So we'll demonstrate how to pick up the PSV size from the codes and standard. So all these programs, all these models and the training program are arranged in such a way that the process designer actually gain confidence. So you'll be able to perform in your day-to-day design activities. So because I have seen many people, because this course is a very important course for not only the people who are working in the process department, but people who are just, because I have seen in many companies actually, after graduation, they just enter the company. So they are putting there's no proper training. Actually, there is no proper training department in many design consultants. They are just attached to a lead engineer. The lead engineer doesn't have time normally to teach the juniors. So the junior somehow actually manage here and there, pick up something and they submit the document. Finally, it becomes a the document, and when it goes to the meeting, the client will say that you are done rubbish. That's all, because you don't know how to do the design, because it was done by a junior engineer who doesn't know the engineering, who doesn't know the course standard. Okay, so the modules are designed in such a way that when they do the design, what codes and standard to be followed, what is a good engineering practice to be followed. Okay, so I suggest, actually, I recommend this course for all process beginners, and not only beginners who are already practicing, and in addition to the other disciplines like mechanical, electrical, instrumentation especially. So undergo and get benefited.